The idea was the application drives the creation of the data model. So, okay, questions, comments while I take a drink of water. Thoughts? Does that all make sense? I was expecting to be beat up about the foreign key comment. Everyone's still asleep? Okay, cool. Let's see if we can continue to wake up here. Okay, let's talk about Planet Orm of the two worlds. So, the problem. The application programmer needs to get the data relational database. Okay? That's a pretty common problem. The application programmer is handed an SQL manual. Let's say we're in the early 90s. Say, oh yeah, okay, here's the API, thunk. And the application programmer says, oh, great, okay, got it. And starts writing code. And the code looks kind of like this. So we declare this cursor object, and you call this DB connection to create it, and we say, okay, well, let's find an order, and then we do say, oh, I have to learn how to do a select. Okay, I kind of wasn't counting on that. So we do this select, and oh right, I have to use a star here, and I'm not sure why, but it just says do a star because otherwise it breaks. And we declare a result set, which is this object that I have to do, and I do a fetch results. And I kind of have to know that there's one object here because there's an order. I'm not sure why that works, but I played with it till it works. And now I have to start copying the fields out of it, and then I quit and become a tour guide. Because I'm going to realize my entire rest of my life I'm going to be writing functions like this. So that's not acceptable. Well, programmers are being programmers. They say, ah, okay, got it. What we need is an interface layer so I don't have to write this stupid code all the time. So, well, let's see. A tuple in a database is a collection of fields. That's okay, got it. An object has members, which are data fields. Okay. A table is kind of like a type. You know, you create this table, it persists, it has a set of fields. That all, okay. And a class is a type that has fields and persists, and you know, frequently they kind of have the same name. You know, I have an order table and an order object. You know, it's all sort of kind of makes sense. Huh, okay. I know, I got it. We'll map a class to a table. Each of the columns of the table can be a member of the instance of that class. I am a genius. And we can create and save methods on a base class or something. I guarantee you, every single programmer who has ever had to write to a database before the existence of an ORM for their language had this thought. And we can keep a flag in the object that says, has this been written to disk or not? Or I know, we'll just set the primary key field to null, to nil, to an empty pointer, and then when we write it on disk, we'll set that, and that's how we know we can write it on disk. And we'll figure the rest out later. How hard can it be? So we write this. Okay, we just do this customer order retrieve and this, and we cancel the order because we didn't want that guy's business, and we save it, and we're done. Wow, life has suddenly become 100 million times better. I do not have to quit my job. Problem solved. Just a few details. One or two. You know, we can. So like, how do we know to do that? You know, do we have to write this big accessor method? Well, that's gross. We don't want to, you know, have to write these giant marshalling and unmarshalling methods. People have done serialization in objects, and that's no fun at all. So, how do we know to create a new row for a new object we've instantiated? Do we do this nil pointer thing, but what if it's an integer and not a pointer? We could reserve a value of 0 to mean this hasn't worked. Like, this hasn't been, okay, that's an interesting question. Oh, so joins, yeah, okay. That's interesting. Well, people don't do joins, do they? I mean, I actually had people say, it's like, well, how often do you really do a join? This is from an application programmer. It's like, because there is no object that corresponds to the results of this join. So what do we do? Huh, okay. Well, how bad can it be? Couldn't be that hard. Yeah, we'll figure it out. And then, so in the history of these things, I mean, we were having these conversations in the early 90s at the latest, back when we were trying to figure out how to do this with C++ and Ada. And then 1998, and Comic Sans came along. Back then, Java was kind of the language of choice. That was kind of what the cool kids were using. And But our DBMSs were still kind of in the hands of the priesthood. You know, you had specialized data people. You bought these really expensive Oracle licenses. So there was this distinction, and the application programmer wasn't expected to come up with a schema. There obviously people can quote any number of counterexamples, but that was kind of the culture that back then. We hadn't moved to today's model. But there was a lot of money to be made writing a database-centric program. I mean, basically, startups were throwing money left and right on really, really expensive database editors. You know, where you presented a web page that edited your underlying pet food database. You know, so suddenly learning about databases and editing these things and not writing all that code became really important. And we needed a solution, like now, please, because we're not going to teach these people how to write these complicated joins, and we're not going to be anyone with a pulse who can claim to know Java gets a job. So, and no one's going to use J2EE. I mean, let's not be crazy here. So, so along came your DBMS approach, pioneered by Hibernate, still in use to this day. Hibernate version 3. The idea here basically was you design a database schema because smart, people, really well-compensated people who understand databases were finally getting some respect, design the schema. And then you write these mapping files because the way you did things back then was XML. If you weren't doing XML, you were not serious. XML was the way you showed you were a real programmer back then. And then use the ARM to convert results into collections of objects via these mapping files. And has its own, even had its own query language, which looks exactly like HTML or like SQL, but has an H. Okay, and colons. Colons are important. So the problem is solved. Ta-da! Okay. Oh, yuck. Okay. For some definitions of solved, I guess. So, okay, we're getting there, but still some problems. We don't have tedious object copying, huge advantage, and I'm not being sarcastic, unlike most of this talk, about that object copying stuff really blows, and anything you do to get away from it is important. But, so we did tedious XML files instead. Okay, that's, I guess, an advantage. You only have to write it once. You only have to write well, all right. It's better for some definitions of better. You don't have to learn SQL. And we're going to come back to this point over and over again because you didn't even, but you didn't have to learn HQL, which is basically SQL, except you use the object names instead of the column names. Okay, I guess that's better. Whatever. But one thing Hibernate did that was very good is you can model these joins. You can model joins in the XML file, so that there doesn't have to be a one-to-one mapping between object classes and tables. So if you can't create these joins super easily on the fly, at least as I'm talking like Hibernate version 1. Hibernate's gotten much more sophisticated over the years, but you did get joins because again, database people were largely driving this, and they knew about joins, and they said, well, if you can't do joins, you're not really solving the problem. You do have to create object classes for the results, but that's Java. You have to model it in an object somehow, unless you do it as associative array. You can't do that, of course. Then came along this idea of annotations. It's like, once Java got annotations, they said, okay, let's jettison this XML file, because except for people who are really, really obsessive, no one likes these giant XML files. I mean, there are people who claim to, but I think they're kind of like have Stockholm syndrome. They've been abused and they've been beaten by these XML files a lot. They think they're on their side. It's like, why don't we, all these do is say, this field equals this column, this field equals this column. It's like, this is really stupid. Let's just say, use Java introspection and create this XML, the mapping file essentially on the fly. And then annotations came along, well, this is a lot nicer. You have to create these tupleizers, which basically, that copy code we didn't want to write, ta-da, it's back. But okay, it's, getting there. There's not too horrible. And we can specify the mapping in the code. No accident. One less thing to get wrong. I mean, one of the things I never understood about these XML files is you're moving something the compiler can check from something the compiler can check in the form of the Java into this XML file, which the compiler can't check, and you just get a runtime error. Okay, and for some definitions that's good. Okay, whatever. Maybe my brain's too small. I don't get it. We use Java introspection to calculate the schema. Okay, not bad. Oh, of course, the schema actually has to match. You have to get it right, It's or you get these somewhat obscure exceptions flying out of the bowels of Hibernate. But okay. But come on, why can't we just create the class? We're still having to write all this stuff in two separate things. Eventually, this became the don't repeat yourself principle in Python.